dear students, welcome back to my new class. In my previous class, I have discussed some problems from the exercise of indices, okay, or exponent. In your class, the chapter name is exponent. Okay, up to 4 I have discussed in my previous video, and today I would like to solve the exercise problem after 4. Okay, so hope you have understand and you have got the idea about the exponent. Okay, if you are having any problem, then you can ask me later. So let's go to solve exercise problem, and by today we will complete the chapter. Okay, so see the first problem. For fourth one, you have to factorize 33600. So 33600, first divide by 2. You have to divide by least number, okay, least prime number. So divide by 2, then 2 1s are 2, 6 2s are 12, 8 2s are 16 and 00. Again by 2, then 8 2s are 16, 4 2s are 8 and again 00. Again by 2, then 4 2s are 8, 2 2s are 4 and 00. Again by 2, then 2 2s are 4, 2 1s are 00. Now by 3, then 3 7s are 21. You can divide by 2 again since last digit is 0. 2 1s are 2. Okay. 1 0 and 5. 1050. Next, by 2 again, 5 2s are 10, 2 2s are 4, 5 2s are again by 5, then 5 1s are 0, 5, again by 5, then 5 2s are 10, 5 1s are, now 3 7s are, okay, so 3600 can be written as, how many times 2 are there? 2 into 2 into 2 into 2 into 2. 1 2 3 4 5 6. 1 2 3 4 5 6 into 5 into 5 into 3 into 7. Okay, so this is nothing but, for all these 2 we can write it in symbolic form. And how many 2 are there? 6. So it is 2 to the power 6 into, in the place of this 2 5 we can use 5 square, and this, since their power is 1, so keep it unchanged. So this is the exponent form or exponential notation of 33600. Did you get it? Hope you understand all these things. Note down, and remaining all the problems which I have not solved in the class, this part is homework for you. Okay, next. So before start to solve the fifth number problem, I am going to discuss a theory part, a small theory part, which you will understand, which will help you to understand the fifth number problem. Okay, look at the board. Suppose to exponent number 2 to the power 5 equals to 2 to the power x is here. This is an equality. Okay, that means 2 to the power 5 must be equals to 2 to the power x. See here that base are same. In left hand side base is 2 and right hand side base is also 2. Okay, then what about 5 and x? Now my question is there any chance that x and 5 will be equal? Yes, x and 5 must be equal. Why? Since base are same, so if left hand side and right hand side wants to equal, if left hand side and right hand side are equal here, then power must be same. So we will get a message from this line that if for two exponent numbers are equal, if two exponent numbers are equal with their same base, then their power must be same. Power means index must be same. And converse is also true. If for two exponent number are equal, suppose I am considering this part, that x to the power 3 equals to 5 to the power 3. Okay. First make the difference between these two. Here base and base same, and power, one left hand side index is 5 and right hand side index of power is x. And for the second one, here power same but base are different. So for this case, if base same, then we conclude that their power must be same. That means we can conclude from here that 5 must be equal to x. That means this 5 and this x equal. And for this case also, since power same, so we conclude that x and 5 also same. Exactly left hand side and right hand side should be the same. After that we can use this sign equal. Okay. So since 3 and 3 same, so x and 5 must be same. So we can write a rule from this line that you have to note down, okay? If x to the power m equals to x to the power n, then what? See here x same, that means base same, so power must be same. So then we conclude that what we conclude, x same, so m and n must be same, so m must be equals to n. Okay, this is the first one. And second one, if x to the power n equals to y to the power n, see here power same or index same, so we conclude about the base, that base must be same. Then we conclude that x equals to y. These two information in rough words you can keep in your mind, that if power same, then base must be same, and if base same, then power same. Okay. Now go to solve fifth number problem. Note down all these things. Fifth number problem is find the value of x first one solution. See, given that minus 5 whole to the power x equals to minus 125. Okay, so minus 5 whole to the power x equals to minus 125, it is there, and we have to calculate the value of x. So according to the previous theory, if we can convert the right hand side into the form of this, into the form of exponent with base minus 5. Suppose the right hand side, if we get minus 5 to the power 100, in the place of minus 125, if we can write minus 5 to the power something, then we can conclude that x must be 100. Is it clear? So we have to try to express 1 to 5 into the power. So 1 to 5 can written as by 5, then it will be 25, and by 5. That means in the place of 125 we can write minus 5. So the left hand side keep unchanged, equals to, in the place of 125 minus I kept here, in the place of 125 we can write 5 cube. Now minus 5, here base is minus 5, but here base is not minus 5, we have to convert it. Here minus of 5 cube, that means 5 cube is our exponent number and minus is there before. So we have to convert it into the base minus 5. So if we consider here the minus in first bracket, then see minus cube means minus and 5 cube. Now we have the same base, see minus 5 to the power x equals to minus 5 to the power 3. So from the previous theory we can conclude that x must be equals to 3. The reason is what? Since base are same. This is the reason. So this completes the solution that x is 3. Okay. Next, problem number 2. Note down all these things. So this one done. Next, problem number 2. Problem 2 is there, x to the power 4 equals to 16 by 81. Very easy problem. Since in left hand side power is 4, there is no chance to change this left hand side, so you have to convert the right hand side into exponent form with power 4. So this can be written in the place of 16, we can write 2 to the power 4. Why? Since 2 into 2 into 2 into 2, if you factorize 16, then you will get this part. So 2 to the power 4. 2 into 2, 4, 4 to 8, 8 to 16. So 16 in the place of 16 we can write 2 to the power 4, and in the place of 81 we can write 3 to the power 4. So this is together we can write 2 by 3 whole to the power 4. Okay. So now we get x to the power 4 equals to 2 by 3 whole to the power 4. So since now here power same, power and power same, so we can conclude about their base. Their base must be equal. Therefore, x equals to must be 2 by 3. Okay. And the reason is since index same in both sides. So this is complete the second solution. Hope you understand this thing. Next, fourth number. This one that I am solving for this line only. Okay, fourth number. Okay, in left hand side 3 by 7 to the power x plus 1, keep it unchanged and try to convert the right hand side into the exponent form with base 3 by 7. Okay, our target is this. So 3 by 7 to the power 3 by 7 to the power 3 is there into, now this can be written as minus to the power 4. Minus to the power 4 means we have to multiply the minus 4 times. So minus into minus plus, plus into minus minus, and minus into plus again plus. So since minus power is even, so it will become plus. So it will be 3 by 7 to the power 4. Now see, for first exponent and for second exponent, they are having same base and they are in multiplicative form. So by the rule of exponent, we can add the power. 3 by 7 to the power x plus 1 equals to 3 by 7 to the power. If we add this power, then it will be 7. Now, our conclusion. In both sides, base is 3 by 7 and base is 3 by 7. So base equal, so we conclude about their power, then power must be equal. So from this line, we conclude that therefore x plus 1, this is the index of left hand side and index of right hand side is 7. Okay, now solve for x from here. Therefore x equals to 7. Just we have to consider this term in another side. So 7 minus 1 equals to 6. This complete the solution. Understood? Okay. Next. Is given, simplify h to the power. Okay, next 6 ones. See, simplify x to the power a by x to the power b whole power c into x to the power b by x to the power c whole power a into x to the power c by x to the power a whole power b. We have to simplify it. Okay. Very easy. Repeatedly we will use the law of indices. Okay. So see the solution. I am solving for here. Okay. Equals to, since this power c is outside of the first bracket, so we can distribute this power over numerator and denominator. So if you distribute the power over numerator, then it will be x to the power a is numerator and the power, if we take c, then x to the power b, again if we take the power, then c into. Similarly for second two factors also, x to the power b into a by x to the power c into a again into x to the power c whole power b by x to the power a whole power b. Now you know that we can multiply this power. So in numerator this first will be x to the power ac by, for this part, x to the power bc into, this is x to the power ba, and for this x to the power ca into, for this part x to the power bc, c into b, bc or cb whatever, and x to the power ab. Now look at the board. In the place of b we can write ab also. Okay, b and ab same thing. X to the power ac is there and x to the power c is there. C and ac same thing, so we can cancel out over numerator and denominator. X to the power bc, x to the power bc same thing, so we can cancel this, and x to the power ab, x to the power ab. So all the term is cancelled out. So ultimate answer is 1. In the case of division, the answer will come 1. So this complete the first solution, 6 ones. Note down this. To simplify this, 6 3. Simplify 3 to the power n plus 2 minus 3 to the power n plus 1 by 7 into 3 to the power n plus 1 plus 5 into 3 to the power n. Okay, we have to simplify this. So we will apply the law of indices. Solution. I am solving from here. Okay, equals to, just try to remind that x to the power m into x to the power n, it can be written as x to the power m plus n. This is the law of exponent. So in the place of x to the power m plus n, again we can write x to the power m into x to the power n. Just we have written here reverse way, that means left hand side and right hand side. Just we change the left hand side and right hand side. Is it clear? So we apply this. So in numerator c, 3 to the power n plus 2 is there. So it can be written as 3 to the power n into 3 to the power 2, that means 3 square. Is it true? Check. Then since base are same, so you can add the part. So n plus 2 will be there. So in the place of 3 to the power n plus 2, you can write this one. Minus is there, this minus. After 3 to the power n plus 1, so 3 to the power n into 3 to the power 1. 3 to the power 1 is nothing but 3 only. For the same case, denominator, in the case of 3 to the power n plus 1, we can write 3 to the power n into 3. Only for 3 to the power n plus 1. Plus 5 is there, keep it unchanged, and 3 to the power n. There is nothing to do. After that, see, there are two terms in numerator. First term, second term. So 3 to the power n is present in both of the terms. So we can take the common 3 to the power n. So we will take 3 to the power n. Then for the first term, the left term is 3 square. 3 square means 9. Okay, I am writing 3 square minus 3 by, if we take common 3 to the power n in denominator also, 3 to the power n common, so left hand is 7 into 3, 7 into 3 plus for the second 5. Here 3 to the power n, 3 to the power n cancel out, over numerator and denominator same term, the case of division. Now, so the numerator will be 3 square minus 3, 3 square means 9, 9 minus 3, 9 minus 3 is 6, by 3 7 is 21, 21 plus 5, 21 plus 5 is 26. Now cancel out, cancel by 2, then 3 to the 6, 13 to the, so answer is 3 by 13. This complete the solution. Understood? Okay. This is problem number 6-3. Next, 6-4 is homework, same as 6-3. Now I will solve 6-2. 6-2. This. We have to simplify this solution. Okay, see. 6-2. Simplify 3 square by this. I am solving for here. Equals to 3 square. Since outside of the first bracket minus 2 is there, so we can distribute the power over numerator and denominator. So one numerator 3 square was there, and we can write minus 2 by 5 to the power minus 1 also there, and minus 2 into. Similarly for second one also 10 to the power minus 3 by 15 to the power minus 3 into 1 by 6 to the power minus 1 can be written as only 6. Okay, since x by this 6 by 1 to the power 1, we have used here that x by y to the power minus m can be written as y by x to the power m by the rule of this one. That for this minus we have to consider the reciprocal of this fraction. See, we have removed the minus, but we have considered here the reciprocal of fraction. X by y was there, we have considered y by x. So here also for this minus we have used 1 by 6 was there, then it will be 6 by 1. Okay. Next, this is the numerator is 3 to the power minus 4. We can multiply these two, and this is 5 to the power minus 1 minus 2. That means minus 1 into minus 1 plus into 5 square only into 10 can be written as 5 into 2 whole power minus 3 by 15 can be written as 3 into 5. In the place of 15 we have written here 3 into 5 and minus 3 was outside, and 6 by 1 is 6 itself. Okay, so equals to 3 to the power minus 4 by 5 square into, we can distribute the power since multiplication is there, so we can distribute the power, so it will be 5 to the power minus 3 into 2 to the power minus 3 by, same case for the denominator also, 3 to the power minus 3 into 5 to the power minus 3 into 6. 6 can be written as also 3 into 2. You can write in this way also. Okay. After that, okay, note down this part. I am solving in top of this line. After this line, okay, 3 to the minus 4 and 3, 3 to the minus 4 and 3 equals to 3 to the power minus 4. Since these are in division form, so minus of minus 3, in the case of division power should be subtract, so minus 3 and since they are in base, same base, and 3 is in numerator and power is 1, so we have to add the power. Understood? So all the cases of 3 has gone. Now case of 5 into 5 to the power minus 3 is there and 2 is there. These two are in division form, so you have to subtract it. So minus 3, if we subtract this part 2, then it will be minus 2, and one more 5 is there, this one. With this and this it will be again negative, so minus of minus 3. Okay, so gone the case of 5. Now left is 3 gone, 5 gone. Now 2 is left. No. Okay, into 2 to the power 3 minus 3 is there, and in numerator also 1 is there. So minus 3 plus 1. Clear? Now solve it. Then 3 to the power, this is nothing but minus 4 minus plus 3 plus 1 into 5 to the power minus 3 minus 2 is minus 5, and minus plus 3 into 2 to the power minus 3 plus 1 is minus 2 equals to 3 to the power 3 plus 1 4, 4 minus 4 0, 3 to the power 0 into 5 to the power 2 into 2 to the power, in the place of 2 to the power minus 2 you can write 1 by 2 square. Okay. Next, 3 to the power 0 means 1, 5 square means 25 into 1 by 2 square means 4 equals to, if you multiply the numerator then 25, 1, 25, and this is 4. This completes the solution. Okay, hope you understand. So this completes the chapter also. This completes the chapters, and remaining all the problems which I have not solved in my class, you have to solve by yourself. Okay, so this completes the class, and in my next class I will start a new chapter.
Please subscribe my YouTube channel and press the bell icon so that you get the notification of all updates.